Okay, so continuing with the part 1 of the transmission system design essential that we were discussing earlier. So we have just discussed how you need to select the tire size on the basis of velocity and the torque required. Okay, so now I have told you this one thing. There are two parameters on the basis of which the tire size is needed to be selected. There are many other parameters. As of now, we are just focusing on two. First is on the basis of velocity, and second on the basis of this complete college of acceleration, your payload capacity, your towing capacity, and your gradient. That is basically the load that is required, right? Load. And this is the velocity. On the basis of these two, you will be deciding what variable tire size is required. Now, there is also one more very important concept. Similarly, you can simply come up with any kind of motor in the world. You can come up with any kind of engine in the world, and you will say that I am using the engine which is producing 1000 Newton meter of torque. Or say, for example, this particular motor or this particular engine is producing 10,000 of RPM. Okay, so someone would come up and say, why don't you directly connect your tire with this motor or with this particular engine, having 1:1 of gear ratio, and at this particular way, you will be having 10,000 RPM at the tire. If you are having 10,000 RPM at the tire, it means you would be having a very great velocity. Say, for example, if I'm using 20 inches of radius of the tire, 25 inches of radius of the tire, I will be having velocity in reciprocation to that. I will come up with different velocities. But is it possible for me to have that particular value of velocity in my vehicle? Right? I need to figure out this thing as well. Would I be able to have, or would I be able to uh, sustain a velocity of 100 km per hour, 200 km per hour, 500 km per hour, 1000 km per hour in my vehicle or not? Right? So even in this particular scenario, you will find out that there is a restriction. You cannot have any value of velocity in your vehicle. You cannot have it. So this restriction comes up because of the slip in the vehicle. Because of the slip in the vehicle, you have got this particular restriction. Okay, so what this restriction is all about, let's just talk about it as of now. I'm not going to get into the entire numerical as of now, but just to give you this particular understanding. So you know this thing that this is my tire assembly having the inertia I, and it is tending to move at an RPM of omega. So this is the torque. Okay, this is the torque generally you can say, or the momentum with which you want to move your vehicle forward, right? Momentum, the angular momentum. Or if I say the torque, you can say I into alpha is the torque with which you want to move it forward. I also know this thing that alpha is equals to A maximum, or just say A divided by R. Okay, R or I square R, right? I also know this thing. Now on the basis of this, if I make this distinguishing between the power supplied by the engine and power that my tire is sustaining, the torque that my tire is sustaining, and the torque supplied by the engine, if I come up with this particular comparison, you will find out that the maximum torque that your engine can sustain would be having a certain limit in comparison to what your engine is producing, and which generally depends on the weight that it is taking up. The weight, right? It means to have a velocity of 100 kmph, or to have a velocity of 200 kmph, or to have a velocity of 500 kmph, the load is needed to be increased. Yes, up till now we used to say to increase the velocity you need to reduce the weight, but at the same time there is certain limitation. To increase the velocity to a certain limit, after a certain limit, you also need to increase the weight, you also need to increase the load, because this load will justify how much traction do you have. Would it be able to move the vehicle forward, or will your tire start slipping over the ground surface? So for example, if I'm having a very powerful motor being used in my vehicle which does not have sufficient weight to cause the traction to move it forward, what will happen? My tire will start slipping over the ground surface. It will not move forward. It will start slipping over the ground surface at that particular torque, at that particular RPM and torque. Please remember this one thing. Your engine, your tire does not know that if you want to move the vehicle forward or not. It only knows this thing that I have got this particular shaft which is required to rotate at this particular RPM, carrying this particular value of load. Your engine, your motor only knows this thing. It is you who has implemented the use case of this particular motor in moving a vehicle forward by having the frictional surface contact between the tire and the road. right? So entire motion of the vehicle does not only depend on the RPM, torque, power produced by the engine or available at the tire, but it depends on the traction limit. Yes, my dear friends, everything at the end depends on the traction limit that you have in your vehicle. So even the maximum acceleration that you have in your vehicle depends on the load. The maximum torque that you can have in your vehicle also depends on the load and the radius of the tire, particularly the load that is acting on it. Okay, particularly the load that is acting on it. That is the maximum load acting on it. It depends on this. It depends on this. Okay, sometimes people also comes up with, if you further derive it, you will find out 2 by 3 times of G of WR by W. WR, if your vehicle is rear wheel driven, WR is the weight on the rear tire, W is the total weight of the vehicle. Okay, similarly the maximum torque that you can have also depends on the total weight, also depends on the total weight of the vehicle divided by the radius of the tire, not 2 by 3 2. Or it also depends on if you are having the rear wheel driven, front wheel driven vehicle or the four wheel driven vehicle. It changes accordingly. This proportionality changes accordingly. hmm. When you're going to make this connection, this is my engine and this is my tire. Now between them a particular connection is needed to be established. You can say the gearbox, differential, clutch mechanism is needed to be used. The torque required to move the vehicle forward is 100 Newton meter. Okay. The torque produced by the engine is 20 Newton meter. My dear friends, please remember this one thing. This particular value of 100 Newton meter will not remain constant. As you increase the velocity, as you change the track on which you are moving a vehicle, this value will also change. Okay, this value will also change. That's why you have to have different gears. We used to have different gears which does not only increase the velocity but also reduces the torque. Say for example, if I need to start my vehicle, I cannot simply start my vehicle at the fifth gear. I need to move my vehicle from the first gear onwards, because at that time I need the high value of torque. And as you shift your gear from lower value to higher count, you find out the torque reduces but the RPM of the tire increases, so velocity increases. In the beginning, when your tire wants to just break free of the stationary position, that means you need to change the value of static friction to kinetic friction, and then from kinetic friction you need to change its value to rolling friction. My dear friends, you will find out the value of rolling friction is almost 1 by 10 times or even lesser than that in comparison to the kinetic friction, the kinetic sliding friction. Okay, if I need to compare between the sliding friction and the rolling friction, you will find out the rolling friction is 10 times lesser or even much lesser in comparison to the sliding friction. So we got this particular value. Now we need to determine what this mid particular geometry is needed to be established, how what all components are needed to be established. So you will be having different stages of gear. You will have the one stage reduction, you can have two stage reduction, three stage reduction, and when you do so, you just want to focus on the stability, you want to focus on the losses. There should be a lesser count of inertial losses that you will be having at the output shaft of your gearbox. Inertial losses should have to be as less as possible. But the most important thing that the student team, the Formula student team should have to focus on is what kind of differential you will be using in your vehicle. Will you be going up with the open differential? Will you be choosing the closed differential, or you can say the welded differential, or will you be going up with the limited slip differential? What kind of differential will you be using in your vehicle? Now undoubtedly I can just say one thing, for all kind of your needs you will find out the limited slip differential is best of all kind of these particular differentials I have just said. So why and how? Like you can go with the open differential, you can go with the closed differential, you can go with the unlimited slip differential. It's entirely your choice. It entirely depends on you. But let's just discuss about what all implications these different set of differentials have on your vehicle. So if I talk about the open differential, what do I have? Just simply say this is my one tire and this is another tire. So rather than having this solid shaft connecting them, I'm just going to break the shaft into two pieces. Okay, I'm going to break the shaft into two pieces. Now, in this particular shaft, I will be using one particular gear like this. Okay. Similarly, I will be using one gear in here. Both are bevel gears, right? Now, these bevel gears are connected with any other bevel gears. Huh. So, this is a set of 4 bevel gears connected together at the angle of 90 degree. At 90 degree, I have connected these 4 bevel gears. Okay, just excuse me for a moment. Just excuse me for a moment. Okay. Now these are 4 bevel gears connected at 90 degree to each other. Now what I will be doing, I am going to have my power source. So this is my engine, and my engine is providing certain power. Now this engine power is connected with one ring gear. One ring gear. Okay. So this is my ring gear which is connected with another small bevel gear. This gear is providing power to my ring gear. And now with this ring gear, I have attached my this particular gear mechanism. With this particular ring gear, simply say this is my ring gear, I have attached this particular gear. So now how is it working? How is it working? If my engine is providing power, this particular ring gear will move, this particular ring gear will rotate. When this ring gear will rotate, it is fixed connected with this particular gear. Fixed connected with this particular gear. If this gear will rotate, each of this system will start rotating. Now this particular tire is connected with this gear. This particular tire is connected with this particular. So remember this one thing, the tire is not connected with this ring gear. Tire is connected with this small gear, the pinion gear. Okay, both of them are connected with this particular set of gears. Okay. Now, if it is rotating, it will, because it is fixed, this particular pinion gear is fixed with the ring gear. So if this ring gear will rotate, this pinion gear will also start rotating, But there is a condition. But there is a condition. What if I say this particular tire is not rotating? I restrict the motion of this particular tire. Then what will happen? You will find out alone this particular tire will keep on rotating without providing any force on this particular tire. Just to make it simple, let me just make another diagram to simply make you understand the concept of this particular differential. Please make sure that this particular differential is also regarded as the open differential. So now this is my engine, sorry, this is my tire, this is my engine, my power is being connected to it. Now, these two shafts are not connected together here. So I have broken them down. When I broke them down, I am just simply using one spoke here, two spokes here. Now, if I want both of these tires to be rotating together, I will be placing one arm here. When I push the force, when I apply the force on this particular arm, both of these tires will start rotating. Both of these tires will start rotating. But what if I restrict the motion of this particular tire? Then what will happen? Nothing. See, this is a pivot here. Okay, this is a pivot here. So I will apply the force. This tire will rotate and this tire will not rotate. That's absolutely fine because I have got the pivot connected here. Furthermore, if I increase this number of spokes, you will find out my entire system will become more effective. Will become more effective. Here also I am using one pivot. Here also I am using one pivot. This entire system will become very effective to work in this particular scenario. So to provide this particular power to this spoke, I'm going to use the ring gear and I'm going to use the pinion gear from the engine. This is how this particular system will work. Now, there's a restriction. It only provides power to the engine which require more RPM. It only provides power to the engine which require more RPM or which require lesser traction. That is why open differentials are not used in all the conditions. Open differentials are not used in all the possible favorable conditions in the vehicle. So what will happen if one of my tire, oh, I am less pages. So let me just add one page here. I'm just adding one page. Oh, I've simply copied the other pages here. This is fine. Okay, I have got few blank pages now. So simply just say, if my vehicle is moving forward, my tire, one of my tire is on asphalt, okay, and the other tire is on ice. Now, this particular tire requires 60 Newton meter of torque and this tire requires 15 Newton meter of torque. What will open differential do? Open differential will limit your torque to 15 Newton meter only. To 15 Newton meter only because it depends on RPM, right? So this is the drawback of open differential. Okay, what if I use a closed differential? Closed differential is like you just have the different power source, that's fine. You need the vertical power source, that's why using it, but it is fixed. If one tire is rotating at 100 Newton meter, the other tire is also needed to be rotated at 100 Newton meter only. But it does not mean that the effective torque will increase to 200 Newton meter. No, as a system, as a whole, it is having the 100 Newton meter of torque. Okay. In the case of limited slip differential, it is bit different. In the case of limited slip differential, what does it do? It limits the torque. Okay, it limits the minimum torque, maximum torque it is required to move the vehicle forward. So again, I will be using the same kind of system. One bevel gear, another bevel gear, one more bevel gear, one more bevel gear. Okay, this entire mechanism. Okay, okay. Now I have connected it with the ring gear, which is further connected with my engine. Okay, now what I will be doing between this ring gear and this particular gear here and the output, I will be using the clutch plates. I will be using the clutch plates so that if on one of the tire, if one of the tire, the pressure is more, the torque required is more, these clutch plates will slip. These clutch plates will start slipping. Okay, now see, this is the ring gear. Inside this ring gear, I will be having the splines. Okay, I will be having the splines. Okay, so now I will be having one splined hub connected with this particular clutch plate. Hmm. Connected with this particular clutch plate. It is further connected with my smaller gear. With my smaller gear. With the help of splines. With the help of splines. Okay, or let me just do it in a way. Hmm. Ring gear. Ring gear has got this particular connection to accommodate this particular bevel gear. Okay, it means these two bevel gears, now these two bevel gears, you can see the pinion gears can freely rotate along this particular axis. Okay, and if it is rotating along this axis, then these two gears will also rotate. Now in the open differential, what I had, there is no connection between the input shaft and the ring gear, and there is one more bevel gear connected like this. Again, one more bevel gear connected with the output simply. Output tire, output tire. This is the tire, this is the tire. Please remember, there is no connection between the ring gear and this in this particular scenario, in the case of open differential. In the case of limited slip differential, between this I will be using the clutch plates. I will be using the clutch plates. So when the pressure increases, what happens? That the splined connection between this and this, between the shaft and between this inside gear, the pinion gear. When the pressure increases, the clutch plates move out, clutch plate moves insideward. So at one point of time, it connects the ring gear with the clutch plate, with this particular gear, or at one time, it disintegrates this ring gear from this particular tire, hence managing your torque. So say for example, at the slippery surface, the torque required is 15 Newton meter. This particular clutch plate will make sure that the torque required on the asphalt road is going to be almost 4 times or 5 times greater than the lesser torque. 5 times or 4 times greater than the lesser torque. Hence, you will be finding out the acceleration of this particular gear system, this particular differential system is going to be greater in comparison to open differential in the case where one of the tire is having lesser torque and one of the tire is having higher torque. Okay, this is how the entire system of differential mechanism also works in your vehicle. So I just want to pass on this particular information to you. We have already covered up the first part of this lecture. We have covered up the second part of this lecture. I hope you got a bit of clarity on how this particular transmission system is needed to be developed, what particular item is needed to be used in your vehicle. Guys, please remember this one thing. ARC Global provides the complete training solutions to student teams, 7 days, 15 days training programs to the teams which are participating in any kind of student motor sports event. You can connect with us at 8800 to get the complete details of our training programs. Just drop me a message on Instagram, just drop me a message on WhatsApp. I will be giving you the complete details of our program. We are available on Instagram with the name of underscore ARC Global. Please find us on Instagram, follow us. You will get the updates of coming sessions from there. So thank you so much everyone for joining in. I know this is not complete, but at least it is giving you a bit of understanding on how to start with what all parameters are needed to be considered while designing your vehicle. So thank you so much everyone for joining in. If you have not subscribed this YouTube channel up till now, give it a subscribe. It will help us in growing. It will also give you the essential information about motorsports engineering. Thank you so much.